Hi, I'm Jack Bolton, and welcome to the third development log for At the Will of God. In the previous video, I mentioned I'd have an exciting announcement to make for this episode, and here it is. The game and engine will now be written in C++ rather than C# as described previously. In this video, we'll go over the reasoning for this change, along with the reasoning for originally choosing C# and what ultimately led to this decision to switch over to C++. We'll discuss the use of a subset of C++ and why, talk over a new design decision for the entire game and engine, and finally go over the libraries we'll be using within the engine now that we've moved over to C++. Another disclaimer here, we're going to be going into some technical detail, so if you're not interested in that, my apologies. We'll have to wait for future episodes to get into the meat of the game's development. Let's begin. So, why did I choose C# originally? Well, the simplest reason for this was for development speed. I use C# every day at work, and so felt it would be the easiest choice. I knew there were going to be some hurdles with using C#, but I knew it was doable. But with that in mind, why change over to C++, especially after getting much of the engine completed? There are a large number of reasons why not to use C# and to use C++ instead. Firstly, to use DirectX, OpenGL, Vulkan, and many other native level libraries in C#, you have to use bindings. These allow you to call C++ functions in C#. There is, however, a marshalling process that occurs each time you switch between managed and non-managed memory between the two languages. That incurs a performance cost. This was the main problem I knew about when choosing to use C#, and felt that the cost wouldn't be too much of a problem since At the Will of Gods will look relatively simple in style, and so would be simple to render. The cost would be invisible. Secondly, there are multiple compilers and methods of running C#. You can use Microsoft's .NET Core, .NET Framework, or an open source multi-platform alternative called Mono. These create IL code, an intermediate language that is then compiled using JIT, or just-in-time compilation, based on the platform it's running on. This again incurs a cost, and really isn't the best option for high-performance applications. Thirdly, managed memory. When using C#, you're in a safe, managed world where memory allocations and deallocations are done for you based on a method called reference counting. C# has a generational garbage collector that checks if your application holds references to objects and collects those references and releases them. While you're able to tell the garbage collector when to collect and release memory, it will automatically happen if memory usage is reaching limitations. C# garbage collection is notorious for collecting while the game is running, causing a horrible stutter in games and applications. On top of all of this, the standard allocator for memory gives us very limited control over where our data is allocated in memory, which has a large impact on performance, especially in performance critical sections. The great thing about code design, however, is that it's almost completely language independent. All of the design work I've done on Daxter so far is completely intact. The engine will still be modular and meet all of the goals I've previously set for it by implementing the same design explained in the building an engine episode. C++ gives us the control we need over memory, the low-level access we need to everything. It has direct links to low-level graphics libraries and has been used for developing games since the start of games development. This isn't to say C++ doesn't come with its own set of issues, however. There's 30 plus years of feature bloat hanging around within the language. I believe the worst thing about C++ is the language syntax and how new syntax and features have been added over the years, creating a very difficult language overall. Many people have tried to combat this by using a subset of the language. This solves the problem to some extent, but I would have to agree with Jonathan Blow here. We need a new language for game development that is built by game developers for game developers. Check the link in the description below to Jonathan Blow's introductory video on his new language for game development entitled IMGUI. As for the subset of C++ we'll be using for Daxter development, I'm looking into using a subset titled Orthodox C++, or C+ for short. Its goal is to keep things simple, use C-like styling where possible, and use a limited set of the available modern C++ features. This has been fairly widely used in open source libraries and communities. Even ID, the developers of Doom, have used this subset. The source code to Doom 3 and Doom 3 BFG can be found on GitHub. A link can be found in the description below, along with a link to a more extensive description of Orthodox C++. With more control over memory, we have a lot more responsibility when it comes to managing the memory for the game and engine. While this makes things a little more difficult, it does allow us to gain some additional performance benefits by using a design based around data. This is called data-oriented design. This design method has been a hot topic for a little while, since there has been a transition happening now away from object-oriented programming due to the performance issues caused by its employment in high-performance applications. In an attempt to keep this video manageable in terms of length, I won't go into too deep detail as to why this is the case, but as a quick overview, processors have become faster and faster over the years. Parallel programming has allowed us to increase the speed of applications by using multiple threads on several cores available in modern processors. This has moved the performance bottleneck from the CPU to memory access, and more specifically to RAM access. To combat this, processors now have CPU caches that contain frequently accessed memory locations. But in order to maximize the benefits of CPU caches, we need to be very careful with how we access memory. Data-oriented design allows us to organize memory in a way that works well with CPU caches, and also allows us to use SIMD to complete tasks much faster. Please find links in the description below for more information. This brings us to a new method of design that I've been thinking about over the past few months. I've labelled it modular data-oriented design. While data-oriented design allows for these nice optimizations, it can sometimes make things more difficult, and this approach I'll be using is a combination of object-oriented programming and data-oriented design. A simple way to describe this is that the larger systems or objects, such as a renderer, each manage their own individual bucket of memory, hence the modular in the title of this programming design method. I could talk about this all day, but I'm sure it wouldn't make for an interesting video for everyone, so I'll end this section here. Since I want to keep the development of the engine and game as simple as possible, I've been looking into a collection of libraries to use that will speed up development greatly, while providing some very useful features such as window creation and management, input, audio, saving and loading of resources, and serialization. The first of these, which I'll be definitely using, is the Simple Direct Media Layer, or SDL library. This is used by Valve within their source engine, and has been widely praised for many years. I've also used this before for window management and audio. SDL provides a great deal of features that are all cross-platform and very easy to use. The second is IMGUI, or Immediate Mode Graphical User Interface. This library is a must for smaller games that require some form of layout editing. It allows for fast UI creation. This won't be used within the final game, but will be used extensively in editor code. I've got my eye on a few other libraries, such as BGFX for graphics, Asimp for loading 3D model formats, and Serial for serialization, but I want to look into these a little deeper before setting their usage in stone for the engine and game. All of the libraries mentioned here are linked in the description below. There we have it, another developer-focused development log. I said I wanted to avoid these where possible, and that is still the case. But again, it was impossible to avoid here since I've spent the past 2 weeks shifting the codebase over to C++. I hope you enjoyed this week's development log. If you want to see more videos like this, please subscribe, and if you like this video, hit that like button. Thanks for watching, and as always, I hope you have a great day. See you next time.